Okay, we'll start in on section 11.2 now. In chapter 11, we're talking about functions, and so for the next couple of sections here, we'll look at some specific kinds of functions. In 11.2, we're going to look at linear functions. A linear function is a function of the form f of x equal mx plus b. Graphing a linear function is the same as graphing a linear equation y equal mx plus b. F of x and y mean the same thing. Okay, and y equal mx plus b is a line, and m is the slope of the line and b is the y-intercept for the line. Okay, the slope of a line containing the points x1, y1, and x2, y2 is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's take a look at an example here. So in problem 10, we want to find the slope of the line containing negative 1, 1 and 4, 3. All right, so here's my formula. By the way, we sometimes say change in y over change in x. Okay, so if you've heard that before, that's terminology that somebody would use to describe this formula, because that's how we compute m. Okay, we want to look at the change in the y values by calculating the difference, and divide that by the change in the x values by computing their difference. So in this problem here, x1 is negative 1, y1 is 1, x2 is 4, and y2 is 3. So I'm going to plug in the numbers here, change in y over change in x. The difference in the y values, it's going to be 3 minus 1, divided by the difference in the x values, we'll have 4 minus negative 1. Okay, or 2/5 is the slope that you would get when you simplify that. Now, I made a graph. They're not asking us to make a graph, but just to point out some other stuff here. I've plotted the points negative 1, 1, and 4, 3 on this graph, and then drew a line passing through those 2 points. Now, the slope of this line is 2/5. Okay, you may have also heard of the terminology rise over run. Okay, that's like you'd see that in every math book where they'd be talking about lines, okay, and slope. And the reason why we would say that is because we're describing the movement that somebody would take to get from one point to the next on a line. You're going to rise up so many units, and then you're going to run either to the right or to the left to get to that next point. In general, if the slope is a positive, you're going to be running to the right, and if the slope is a negative, you'll be running to the left. Okay, so here I've got a slope of 2/5. Rise over run. So if I'm starting at the point negative 1, 1, I'll have to rise up 2 units and then run to the right. Since that's a positive, I'm going to the right 5 units. And that gives me to this next point. Okay, if I go up 2 and to the right 5, up 2 and to the right 5, I can gather up a whole bunch of points on this line, right? Lines that have a positive slope are going to be slanted this way, as you see in this example. Lines that have a negative slope are going to be slanted the other way. Okay, and one way that I like to remember this is a line with a negative slope means that you can make a capital N, whereas you can't do that with the positive case. Problem 11, okay. We're going to graph the line f of x equal negative 2/3 x plus 1 using the slope and the y-intercept. The slope of this line is negative 2/3, so I can know right away that I'm going to be drawing a line slanted in the negative direction here. Okay, and the y-intercept is at 1. So here's 0, 1. I can use as a start point when I draw this line, and then work off of the slope. Okay, rise over run. So I'm going to have to rise up 2 units and then run to the left, since that's a negative, 3 units. Okay, go up 2 and to the left 3, up 2 and to the left 3, or you could go down 2 and to the right 3. That means the same thing, right? You're just going to gather up some points on this line flowing in the other direction. Once you've got a couple of points, you can then draw on the line, and then you'd be done. Okay, problem 12, use the given graph to determine the linear function f of x on the graph. Okay, so what's a formula representing this line here? Well, I'm looking for a form of f of x equal mx plus b. I gotta know the actual numbers for m and b. I have labeled these points that the line is passing through, and so the first thing would be to compute the slope of this line. Okay, change in y over change in x. The difference in the y values, we're looking at 5 minus 3 divided by the difference in the x values, that'd be -1 minus -2, be -1 plus 2, or 2 over 1 is 2. Okay, the slope of this line is 2. Now, I didn't really need to compute m. I could have very easily got a slope of 2 just by looking at this picture that's already there for me, right? If I'm starting at the point -2, 3, and I go up 2 units and to the right 1, then I'm at this next point, right? Up 2 and to the right 1, rise over run. So, okay, I know the slope, that's 2. Now, at this point, you can select either one of these 2 points. It's not going to matter. Both of them are on the line. So I'll just use the first one here. X is -2 and y is 3. And I'm going to find my b value by plugging these numbers into the formula y equal mx plus b. 2 times -2 is -4. If you add 4 to both sides, then b would be 7. So we're looking at y equal 2x plus 7, or using function notation, f of x equal 2x plus 7 would be the linear function that we would need in this problem. Okay, problem 13 is a similar one here. Use the graph to determine the linear function. Okay, and I've labeled these points just so that we can see the what the coordinates are in that. All right, so I'd want to find the slope of this line and the y-intercept just as before. Well, the slope, change in y over change in x, is, let's see here, -1 minus 5 is the difference in the y values, divided by 8 minus 1, that's the difference in the x values. Or -6/7 would be the slope of this line. And of course, I can get that by looking at the picture, right? If I'm starting at the point 8, -1, and I go up 6 and to the left 7, that'll bring me to this next labeled point here. Okay, -6/7 is the slope. So then I want to find my b value. Well, I know the slope, and then I can pick either one of these 2 points. Again, it's not going to matter which one, they're both on the line. So we'll just use the first one. X is 1, y is 5. Okay, and I'm plugging in those 3 numbers that I know here to get the b value. If you add 6/7 to both sides, 5 plus 6/7. Well, 5 is the same as 35/7. 35 over 7 plus 6 over 7 is 41 over 7. Okay, so y is equal to mx plus b means that y is equal to -6/7 x plus 41/7, or using function notation, f of x is equal to -6/7 x plus 41/7. Okay, next thing is a definition. A horizontal line is given by the function f of x equal b, or y equal b means the same thing. Remember, f of x and y are the same here. B can be any real number. Okay, and a horizontal line always has a slope of 0. A vertical line is given by x equal a. A is any real number. A vertical line has an undefined slope. Okay, we'll look at that. Now, first thing is to say that, just an observation here. Notice that I'm using function notation in the case of a horizontal line, but I am not doing that in the case of a vertical line. Why not? Well, a vertical line is not a function, right? I had said earlier that a linear function is just a line. Well, that's not actually completely true. It's still going to be a line that passes the vertical line test. If we have a vertical line will fail the vertical line test, right? If you swing a vertical line across the graph, the vertical line being swung across the graph would intersect the vertical line that's already there infinitely many times, and therefore making a vertical line not a function. So I don't want to be using anything with function notation in the case of a vertical line. That's not a function, actually. Okay, let's take a look at problems 14 and 15 are working with a horizontal line and then a vertical line here. Graph the line f of x equal 3 using the slope and the y-intercept. Okay, so I can know right away that this is a horizontal line. The slope of a horizontal line is always 0. I need 2 points to compute a slope. Okay, so just to maybe verify that, I've created a table here. If I let x be 0, y is 3. Remember, f of x and y mean the same thing. If I let x be 3, what is y? 3. If I let x be anything, what is y? 3. I don't have any x's, right? I always get 3 in return. So it's not going to matter what x is. On the y column, you'll always have 3. Now in this table, I've been able to gather up 2 points, and so I can compute the slope, change in y over change in x. The difference in the y values, okay, 3 minus 3, divided by the difference in the x values, 3 minus 0. 0 over 3 is 0, so the slope of this line would be 0. Okay, if you were to find the slope of any horizontal line, you would always get 0 in the numerator, and therefore a horizontal line is always going to have a slope of 0. When you draw the graph, of course I can plot these 2 points, 0, 3, and 3, 3. Now I had asked you, what if we let x be anything? Well, y is always going to be 3, right? So it's not going to matter where you're at on the x-axis. You can be anywhere, and you're always going to come up to a height of 3 and plot a point. So you're going to have all infinitely many points at a height of 3, creating this horizontal line at a height of 3. Okay, how about problem 15? Graph the line x equal negative 2 using the slope and the y-intercept. Well, this will be a vertical line. A vertical line always has an undefined slope. Why is that? Well, let's maybe just get 2 points that would be on this line using a table, and then we'll compute m. Now, in this table, I'm using it backwards, I'm selecting a y value and getting an x value. The only reason why I'm doing that is because the equation has been solved for x and not y. So like if y is 1, x is negative 2. If y is negative 3, x is negative 2. If y is anything, x is negative 2, right? We don't have any y's here in this equation. Now, I would have 2 points then. Okay, remember the coordinates are x, y here, so it'd be negative 2, 1, that's 1 point on the line, and then negative 2, negative 3, that would be another point on the line. Now I can find the slope of the line passing through these 2 points. Okay, change in y over change in x. So the difference in the y values, we're looking at negative 3 minus 1 in the numerator, divided by the difference in the x values, that's negative 2 minus negative 2, or negative 2 plus 2 in the denominator. Now there's a problem in the denominator in that we would get 0. We know we can't divide by 0 in math, right? And because we don't get a definitive number then in this calculation, because there's a problem in the denominator, we have an undefined slope. Okay, and that would always be the case. When you calculate a slope for a vertical line, you'll have 0 in the denominator, but you know you can't divide by 0, so that's really the issue in stating that the slope is undefined there. Okay, and so I would just draw a vertical line here at negative 2. Of course, I could plot these 2 points also. Right here is negative 2, 1. Also negative 2, negative 3 is right here, and I can draw the line.